Hi class, today we are going to learn how to graph quadratics on our calculator and to use that to solve real-world problems. You can see that our standards are that I can use graphing technology to graph functions, and I can represent and solve problems in real-world context using quadratic functions. The first example says if a rock is flown from a slingshot vertically with an initial velocity of 128 feet per second, then its height h after t seconds is given by the function h of t equals negative 16t squared plus 128t. The first question, part A, asks us to describe what h of 1 equals 112 means for the rock. As we've been learning this semester, the number inside parentheses is the input, and in this case, the input is the time, and the answer is called the output, and in this case, that's the height in feet. So if I was to write a sentence to describe what h of 1 equals 112 means, it means that after 1 second, the rock is 112 feet in the air. So that's a little bit of review. In the air. The second question, part B, just talks about how we can't type h of t into our calculator. Instead of our calculator, we'll use x's and f's. So we're going to take this function, instead of h of t, we're going to write it as f of x, which means everywhere I see a t, I'm going to turn it into an x, because when I ultimately type it into my calculator, this is how I will need to type it in. Then it asks if it's linear, quadratic, or neither, and hopefully you're recognizing that it's quadratic, because its highest degree term is x squared, because of x squared is sufficient for now. Now once we have all that, the biggest thing for this time is we want to actually go and graph it on our calculator. So parts D and E will describe what I'm going to do next. So you can either follow along on your note sheet, but I am going to pull my calculator out now. So in order to graph, again, anytime we want to do something new, we're going to go to our home button, new document, add graphs. And then I type in what we just put under part B, which is negative 16x squared, the square button's over here, plus 128x. Hit enter. And now we said it was quadratic, so we should see a parabola, and more specifically it will be an upside down parabola because there's a negative in front of the 16. Having said that, you can see I can see both sides here, but I can't see the top up here. So part E talks about how we can see that. So we're going to change the window by going to Menu, Window Zoom, Window Settings. Now my X values are fine because I could see both sides. Now because we're in the real world, in theory I could change the x min to 0 because I don't care about time before 0, but I am just going to leave it. My y min, again, I'm okay seeing down there, but the y max, the highest values, I can't see enough of. So I want to be able to see it. We know that it's 112 feet in the air at one point, so let's say I guess it's 200. When I type in 200, you can see I still can't see the top. So I am going to go back to Menu, Window Zoom, Window Settings, Tab, 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 so you can hit Tab to get down there. And I'm going to put 500 this time just to save myself time of guessing again. So that's how I can get the picture that I need to see. Now, if we go back to our note sheet, again, what we just talked about was the x min and x max. So we kept the x min at negative 10, the x max at positive 10. The y min was at like negative 6.7, and I ended up changing my y max to 500. And again, you could have gotten away without showing all of that, but that's where we're at. Now on the back side, I'm going to, off to the side, draw a sketch of what we see. Oops, pretend that looks like a good graph. And then really what parts F through J walk us through is there's going to be 3 key points we want to be able to find on the graph. The first one is called the Y Intercept, and the directions for that are in part F. So we're going to find that one first. So we're going to go Menu, Trace, Graph Trace, and type in 0. Okay, so I'm going to go back to my graph. Again, I hit Menu, Trace, Graph Trace, and again, it actually already shows it as 0, but I would hit 0, and you can see down here it says x equals 0, hit Enter. And you can see that the y-intercept in this case is at the point 0, 0. Now remember from the beginning, we said that this is the input, which is always time. And my output in this case is going to be the height. So back to question F, it says the rock is at height 0 when it is first shot. The second point we're going to find is the maximum or the vertex. That's this one, is the maximum or the vertex. And again, I'm going to find an ordered pair where the first number will represent the time and the second number will represent that max height. In order to do that, we're going to go Menu, Analyze Graph, Maximum, and then ultimately take a picture. So I go back to my graph, I go Menu, Analyze Graph, Maximum. And you're going to see this vertical bar. You can see in the lower left-hand corner it says lower bound. So it's really saying just click to the left of the vertex. Don't try to get right on it or super close to it. It's just got to be anywhere to the left and click. And it says upper bound, so anywhere to the right. So really you're taking a picture of that maximum point. You can see we get the value 4, 256. So I'm going to go back here and label that 4, 256. And again, the 4 represents the time it takes to reach the max, and the 256 is the height of the max. So the maximum height of the rock is 256 feet. It takes 4 seconds for it to reach the height. The final point we need to find is the X Intercept, and it's going to tell us how to do that in point I. It's where it crosses the x-axis. We're going to go Menu, Analyze Graph, 0, and then take a picture of that point. So I go back to my calculator, I go Menu, Analyze Graph. A 0 is the same thing as an X-intercept, and again, this point right here is the one I want, so I go to the left of it, click, go to the right of it, click, and you can see that that X-intercept is at the point 80. Oops, sorry about that. So this is 80, and again the 8 is the time, and the 0 is the height, which makes sense because that's when it's landing. So how long does it take to hit the ground? 8 seconds. So that's what we have to be able to do for this section. Graph it, find those 3 key points, and then be able to describe what they mean in the real world. So number 2 cuts down a little bit, so I want you to take a minute and try graphing this and finding all the information it gives. So pause this and then come back and check it. So hopefully, as you went to graph number 2, you should have gone back home, new document, no you don't want to save, add a graph. And in this case, our equation is negative 16x squared, then plus 32x plus 5. I hit enter. Again, I can't see the top of the graph. So to change the window, I go Menu, Window Zoom, Window Settings. Again, I'm okay with the X's because I can see both sides. The minimum's okay, but I can't see the top, so I said, okay, let's go to 30. Okay, so that gives me an okay picture. So again, what I had here is negative 10, 10. I kept it as the negative 6.7, and I went up to 30. I am going to draw the picture that I see, and ultimately I'm going to use that to find these 3 points. So the first one, part B, asks about the y-intercept. As a reminder, we go Menu, Trace, Graph Trace. You can see now this time this didn't work out as nicely, so I hit 0, enter, and it gives me the nice y-intercept at 0, 5. So I found this point to be 0, 5, and so the hook is at the height 5 feet when it's first flown. Part C asks about the vertex, so I'm finding that maximum up here. To find the maximum, I go Menu, Analyze Graph, Maximum, and then I take a picture. Click to the left, click to the right. Can't see it, move it, and you can see that it's the point 1, 21. So I label it, but then I say the maximum height of the hook. Remember the second number, the 21, is the height, and it takes 1 second to get there. Finally, the X-intercept is this last point. So in my calculator, I go Menu again, Analyze, and then X-intercept is the same as a 0. Click to the left, click to the right, and I can see that it's at 2.15. So it says 2.15, comma 0, which means it takes 2.15 seconds to hit the ground. Last but not least, you're trying to dunk a basketball. You need to jump 2.5 feet off the ground to be able to dunk it. The height that your feet are above ground is given by this function. What is the maximum height of your feet? Is it enough? So really what we're looking for, we're going to end up with a graph. And I need to find this point. Remember, the first value is the time it takes me to reach my max, but this is the height at my max. And really what I'm looking, I need to be able to jump 2.5 feet off the ground, so I'm looking to see if the y value of the maximum point of this parabola is greater than or equal to 2.5 feet, and if it is, I can do it. So this one's a little bit simpler. I just need to graph it and find the maximum. So I'm going to go home, new document, no, I have graph, and this time I have negative 16x squared. And it's just plus 12t, so plus 12x, hit enter, and this time I can even see the whole thing. So all I care about in this one, I could find all the others, but I just care about that maximum. Menu, analyze graph, maximum, click to the left, click to the right. So we can see that it's actually at 2.25 feet. So that point that I cared about was 0.375, which doesn't really matter to me, 2.25. So my max height is 2.25 feet. So no, it is not enough, because I had to be able to jump 2.5 feet off the ground to be able to dunk. So that's how we can graph on our calculators, find those 3 critical values or points, and then ultimately be able to answer the real world questions. Thank you.